Thank you so much, Mr. Hamish. Thank you. And wish you all the best with your hard work. And I just want to say we appreciate you. And I have achieved like 93%. Sanbonani. This is Emma Onokula Wamkizis Bongo. I live in Devon in KwaZulu-Natal, and I was born in KwaHlabisa in KwaZulu-Natal.
Hello, how you doing? I'm Hamish. So you FaceTime here. Make sure you go to my website, because I put a lot of content on my website, and I appreciate any donation. Because with this project going, it means a lot when you're seeing donation. You might think it's too small sometimes that you can donate, but that's what sustain these projects. We have a lot of good intention to change, the picture or how people perceive the African continent. That's why I'm doing this, for the African people and for the African continent. Let's get started. So now, I don't want to understand. They say a 20-kilogram rock lies on the surface of the planet. Okay, so let's say there's a planet here. Let's say this is the Earth. Okay, and these 200. So let's say this is a rock here. So this rock has a 200 kilogram. 200 kilogram is on the surface of the rock of the Earth. Lies on the surface of the planet. The acceleration due to gravity on the surface of the planet. Oh, so we have acceleration due to gravity. Let's say this is G. Which equal to 6.0 meter per second negative 2 meter per second square. Now, state the Newton's law of universal gravitation. The Newton's law of gravitation, it says force is directly proportional, means the force of between the two objects. For example, here the Earth and the rock. You know what I'm saying? So we're going to say the force between the two objects, or you can just say the force is directly proportional to the product of the mass, means product of the mass. Let's call this M1, this M2. So force is directly proportional to that, means this is directly proportional to the product of the mass, but this force is inverse. So force is directly proportional to the product of the mass of the particle. But the same force is inversely. So inversely means this is like direct. Can you see? Direct. But inverse is like this. So force is inversely proportional to the square of the distance between them. You know what I'm saying? Like here you see the distance between the rock and the Earth is this one, means the radius of the Earth. Because from here to the center of the Earth is radius of the Earth or planet. See what I'm saying? So now we're gonna say, let's define. So we're gonna say the force is directly proportional to the force that puts you the product of the mass. Like you say, F is that puts you the mass 1 and M2, means you multiply this mass, and the same force is inverse proportional to the square of the distance between. Is that proportional to the product of the masses of the particle? Like here, mass of the rock and mass of the planet. Planet or Earth? How do I say here? Yeah, Earth is a planet also. Planet, yeah. So it could be any planet. Know what I'm saying? So this is going to be a planet. Some planet. It could be Venus or Mercury. Okay, product of the masses of the particle. And force at the same time, it inverse proportion, means the force, or you can say it in the force also. The force is inversely proportional to the square of the distance between them. Square of the distance between them. Mean the distance between these two masses, like here, the rock and the planet. The distance between them. You know what I'm saying? Okay, cool. So I think this is clear. Okay, so now what do they want? So now they give some data here. Let me explain to you something, because I want you to have it clarity. Okay, let's assume this rack here, it was like somewhere here, not right here on it, because it's on the surface now. Okay, let's say it was somewhere here. Let's say the rack was somewhere here. Let's say this is M1 and this is mass of the planet. So how we was going to calculate, we was going to say the force between the rack and the planet equal, because directly proportional, shows what I'm saying. So it's directly proportional to the product of the two mass of the rack and mass of the planet over the distance square of the distance between them. So what is the distance between them? The distance between them means the distance from the center of the Earth to here, means this is the radius of the planet. So it's going to say radius of the planet plus, you see there's another height here from the Earth to that planet. Let's call it height. So it's going to say radius from here to there plus this height, and then all this was going to square. You know what I'm saying? So, but for this case here, we don't have any height because this rock is on the Earth's surface. See, it's on the Earth's surface. So for that case, and when you write this, what you do, say F, you have to remove this mathematical. So when you remove this, you write equal, and then here you put constant K. G, excuse me, G, which is gravitational constant. So instead of, when you remove this proportionality sign, you write gravitational constant, which is G, which is given. You know, if you check in the formula, you have it, which is 6.6 times 10 power negative 1. Okay? And then you multiply by the mass of here and mass of the second one over, this is here what I'm talking about, radius of the planet plus the height, and then square, and then you plug it in. But then we know mass. So yeah, that was like a rough idea. You know what I'm saying? That was like a rough idea. Now let's go to our business now, because I was trying to go out a little bit just to explain to you. So just in case if it comes something like that, and then you have an idea on how to approach it. Now, so this object now, the rock is on the Earth's surface. According to the equation, is on Earth's surface. So we're going to say force equal is directly proportional to the product of the mass, means mass of the rock, let's say mass of the rock, and then mass of the planet over the distance between them. But what the distance between them? They give us here the acceleration due to gravity on the Earth's surface is mass, or you see, calculate the mass of the planet, So we find the mass of the planet. If its radius, means the radius of the planet, we have, okay, so for now let's just say, right, because this stuff is on Earth's surface, so the only distance between them is from surface to the center. So radius of the planet, because this is a radius of the planet, and then we'll do is square. So we can remove this. So we say force equal, when you remove, and then we have to put gravitational constant. So gravitational constant, which I'm going to show you now, what the value of it. You see now, mass of the rock, mass of the planet over the distance of the planet square. Now, but we know, look, if this rock is here, which force is going to exist on the planet is Fg, force of gravity. Because if it's on here, means even here, if this stuff is here on air, let's say, means it's going to exist force of gravity, because the weight which is going to exert toward the center of the planet. For this case, so we're going to say I'm going to remove this force, because this force is the force of, between them, or the force of, but the force is going to be force of gravity. You know what I'm saying? So this is going to go, and then we're going to write here force of gravity. So force of gravity is mass times gravity. But what is this? This is mass of the rock. Mass of the rock times gravitational force. Let me write big a little bit. So this is going to be mass of the rock times gravitation of the rock. You know what I'm saying? Gravitation of the rock, which they give to us this surface of the planet. The acceleration due to gravity on the surface of the planet means mass of the rock and the gravitational, which is on the surface, okay, equal to gravitational constant, mass of the rock, mass of the planet over planet square. Now let's see, something's going to cancel. Mass of the rock is same thing, so cancel. So I'm left with G gravitational, which is on the surface of the earth, equal to G, which I know, and then multiply. This was cancelled already because we got 1 mass of the planet over the square of the planet square. Now what do we want? Calculate the mass of the planet. Oh, so we're looking for this mass of the planet. So how are we going to get mass of the planet? Gravitational on the surface of the earth we have equal to 6. So I'm going to say 6 equal G. We had G is always given 6 times 6, 7 times 10 power negative 1. So 6 times 6, 7 times 10 power negative 11. Okay, now we looking for mass of the planet, and then over the distance between them we have 700 kilometers. So this is going to be 700 kilometers, but you have to change to meter. How are you going to change kilometer to meter? We must multiply kilometer to meter. You must multiply by 1,000. So I'm going to say 700 multiplied by 10 power 3 means this is 1,000. You can just say 1,000. 10 power 3 means 1,000. And then remember you have to square this. Okay? So now let's find out this mass of the planet. So we can finish. I'll take 6 times all this group. Just do like this. So it's going to be 6 times this, 6 times all of this. But I remember it's in a bracket because of radius square. You see this is a radius and then we square. So times 10 power 3 and then all this square means all this multiplied by that and then equal to this group here, which is 6.67 times 10 power negative 11 times mass of the planet which you're looking for. Okay, so it's the multiplication means you're going to have to get rid of this. How are you going to get rid of it? By dividing by 6.67 times 10 power negative 11. Both sides is 6 times 6.7 times 10 power negative 11. This and this cancel. So mass of the planet equal. So we take that one. So I'll take this one, plug in the calculator. If you plug in the calculator, this corner give us 4.41. So this is going to give us 4.41 times 22 kilograms. So this is going to be the mass of this planet. So big mass. Okay? And easy like that, man. We out easy, man. Thanks. It just wastes your time. You do this question? And it's easy like that, man. Thanks a lot. You know what I'm saying? Look, man, I believe in learning from how I do things. If first time, make sure you subscribe, and you know, you can just go and do donation to our Patreon page. I have a Patreon, I have a GoFundMe. You know what I'm saying? I have all the means of donation because to make this project going, you know, any type of donation, the little that you think is too small for you, it could make a lot of change. And thanks a lot for all your time, you know. Subscribe, don't forget, share this video, circulate to a lot of people, you know, because the meaning of this project, this program, is to help as many as we can. Okay, it's not only for one person or two, because you might think it's not helpful for you, but for somebody next out there, it could be very, very helpful. So thanks a lot, man. And you know, any donation that you did to me, it means so much. I appreciate it, man. It means a lot. Go to our Patreon page, go to our GoFundMe, because we need to have a lot of things. We need to put them together, like camera, you know, and a lot of equipment, so that we can improve on, you know, a lot of angle, a lot of aspects of these projects, you know. Thanks a lot, man. I appreciate and I love you. Peace and love. Bye. You know, this is one of my students of knowledge. You know, she wanted to introduce herself. What's your name? Could you please introduce yourself?
My name is Kali. I
Yeah.
go to Southern Primary School.
Yeah, China Wabantu. China Wabantu is everywhere, right? So this is my other student. His name, what's your name? Matthew, yeah, he's grade 11, man. So his aim is to score distinction, right? So you promise I want you to score distinction this time. And what's your name? Joshua. How much you promise me to score this time?
Distinction.
Distinction. Yeah, so China Wabantu is everywhere, man.
China Wabantu.
China
Everywhere.
Everywhere.
John or Bond.
Exactly. Thanks a lot, man. Appreciate it. Thanks so much. If you had to give advice, which advice would you give to the people or to the students?
Trust Hamish.
Why would they trust me?
No, because it's really good. It actually has helped a lot. I redid first year for maths. It was my own fault, but also I didn't know a lot of the work. And Hamish said lots of hard questions, and it's demotivating sometimes to do the harder stuff. You just want to get done, but it's the hard stuff that makes you realize the easy stuff is easy.
Mama,